we'll talk about the geographic database. When we're talking about this, I want us to hear that the database does not hold map or pictures. It holds a database. A GIS environment holds a database. In terms of that, whenever you're able to call in your database have some relationship and features to produce what you actually want. So database, when it's tampered with, most of your maps, most of whatever you've modeled will actually be tampered with. So one needs to know three things about every feature stored in the computer. What it takes that is actually stored, what it takes and how it is actually related to the feature you want to create. GIS also gives the ability to associate this information with a feature on your map and create new relationships. So your database, the integrity of your database cannot be compromised. Once the integrity is not there, whatever you are bringing out as a graphics, as a presentation, will lack some integrity. Then, in overall, there are so many applications of GIS. I think I try to just try to combine them, but mainly in mineral exploration is actually what most people are actually interested here. That was number one, we highlighted there. In mineral exploration, you can use that. In this, after this, I just try to bring up a project we've actually tried to, we're doing. So we see some of the application, how we try to relate so many kind of maps and trying to come to a kind of a particular point. Then second one, in urban and town planning, you can actually use your GIS. Forestry is very good. You can use your GIS in forestry. In defense these days, you can actually use your GIS. In wasteland development, GIS is actually applicable. Land information system, land use and thematic mapping, business and retails now use GIS too, and facility management also, environmental assessment can actually make use of GIS. The benefits of GIS in exploration is overwhelming, compared to what actually we had in the old days, that most of things are done actually manually. Now, most of things are digital, in the sense that you can carry so much files and information within just in a flash. The advantage now is something else. This can save us a lot of time, and time is money. So mineral exploration can be time effective in this following order if we actually apply GIS in our exploration and in our geosciences. Combining data sets from different sources with ease. Once the format are the same, you can actually combine them and you have what you want. Then you can also link directly from modeling software, such as MapInfo, ArcGIS, and other kind of software. Also, your model can be quickly and easily done these days. Instead of trying to plot in the old days, we were trying to plot a lot of graphs in our hand, trying to connect our contours. I remember in my master's those days, I was given a paper to connect all the contours of anomaly from one point to the other. It was very tedious. So in there, I was asking myself, is this how all these oil companies try to find out the anomaly? By trying to connect all the whole of the contours and try to bring out the anomalies, So, but these days, some of these applications and GIS technologies have gone so far in making this very, very easy for us. So there are varieties of GIS analysis method and quantitative, one can actually use to determine anomalous area immediately and pick up a ground truthing spots, Also the abilities of this old data that are actually in different file formats can actually be converted into the newer file format, and they become compatible with the new layers, So this is some of the benefits of the GIS. This, for example, this is a GIS environment. This is ArcGIS. I will also, maybe if time permits me, maybe I'll just also show some example of a GIS environment using Global Mapper also. and some other one, though time might not actually permit us. So I'm just trying to show us what of some of the powerful things some of these can actually help us do, with ease. If we look at this place, this is a boundary of a particular project area. This boundary, if we measure this boundary, if we, for example, want to measure this boundary is almost, you can see this is 15,000, that is 15 kilometers. Yeah. And this is 15 kilometers. So this is 15 kilometer by 15 kilometers. This is like entire community. So one can actually walk the whole entire place by organizing different data into this environment and be able to say, okay, let me narrow what I want to do to this particular kind of location. If you look at this is actually my table of contents in our GIS environment, the table of contents. This is actually the catalog. The catalog is where you can connect all your data from. And another one is your tool. So now I want to show a few things here. Another one is, now let's look at here at our table of contents. If you look at table of contents here, if you look at my coordinates here, I'm working in meters actually. So if you look at table of contents, you can see a lot of data that actually brought into this environment just to actually try to look at a particular place one could actually work on. If we look at this, we have a series of maps here, 1, 2, 3, 4, up to more than kind of 30 different kind of maps inside this environment. First of all, for example, if the first map I had access to, which is a geological map on a very regional scale, wasn't giving me anything, I overlay this map here. If you look at this map, I'm only having a boundary only here, compared to where I want to walk. This is the granite necks and all that. So it's like a very regional thing for me. So yeah, but actually it also helped me to understand, yes, I'm working within a very basement complex. You understand? Yeah. So that is actually what it actually allowed me to do here. But actually there are might be some kind of intrusions which might actually happen here, or some kind of detailed kind of thing that I might not be able to see for that purpose. Then I have to say, okay, that is just it. Then I try to start working with other kind of data. If you look at this, this is a radiometric ternary plot, trying to bring some discrete kind of characters and attitudes here, trying to show, yes, it's no more. You can see what the other map gave me is not what this is actually giving me. And again, you ask yourself, what is the ability of this kind of layer? What can it do? This layer goes just within possibly about 5, not more than 30 cm beneath there. But this is very powerful tools in terms of trying to look at your lithological boundaries and lithological differences and all that. And also we should understand that most of the supergene enrichment, kind of secondary mineralization, has so much to do, at the surface. There's so much to do, because when we're talking about movement of metals, they move from down to up. And when they move from down to up, there are some anomalies that one can actually see at the surface that can depict that certain things are actually happening there. Then we'll look at, this is the K with our potassium here, trying to overlay there. We'll look at our thorium there. Also, you find out that they're kind of a consistent kind of signature that is actually, this is actually a schist from the ground. Truth, and I can actually tell you that I can explain certain things better because I actually worked on ground here, see so many things we've actually interpreted, but it actually helped us to narrow down so many things before going to the field. And to be frank with you, I would say that it gave us almost 75% or 80% of what we actually found on the system on ground, So some of these structures that were actually shown here are actually found in the field. And you can look at this also. You see this is uranium. Now, if you look at this uranium and thorium, the differences, there are some clear differences in the sense of immobility and capability of some of these elements. You know, you don't expect uranium and thorium might not give you exactly the same thing, but thorium, because of immobility of thorium, they can actually map exactly some specific features in terms of boundaries. You know, when you're trying to delineate water bodies, because of the feldspar, that a weathering of feldspar giving you K, you see more of potassium mapping water bodies, can give you a lot of water bodies and all that. So some of the characteristics of elements could be used to map so many things. Then we try to resolve these layers into different ratios, because here, our targets here, there's a metallic minerals we are targeting here. We are targeting gold, we are targeting nickel, and some other one that actually be associated. But we are going through indirect means, because we might not actually target gold directly. We are looking some accessories here in order to see some zones that are actually altered, or some zones that could give us some anomalies that actually different from what we know, or some places that we can suspect. So that actually we're able to process some of these ratios into the uranium and thorium ratio. Combining different ratios can actually give you some unique features. You know, here potassium and thorium, the power of GIS, actually we're bringing out into one layer. You can digitize it or put it into a format that you can lay all of them to see all of them at once, for you to start looking at. Because most of the times we'll find out that when you reduce some layers to magnetic pole, we're not close to the pole, it distorts most of your anomalies. So what we try to do here, this is reduced to equator. That's actually what we use here. We're able to bring in the 1Ds in terms of Y directions, the 1D in terms of X directions, giving you different features, and we are picking different structures on each layer. You know, you can see this is another layer, but it is a color in one X direction. Then also, this is the total processing and all that. Then we integrate the dam. We brought in the dam. If you look at the dam, you can see what we are saying. The elevation, the topography is a very, very cheap layer to get. You can acquire your elevation anywhere. Like this elevation is 30 by 30 meter resolution. It is good for what we want to do. If we are trying to do some other kind of work that might require a smaller resolution, it might not really be good for, but this kind of work is very perfect. Even the topography shows some unique features that align with some of the layers too. So this is a dam image. Then we'll try to put in the remote some of the extra images here, but we were not able to get something very, very interesting using some of this. So I wouldn't tell you that we actually make use of this much. Then this is also a dam format. Then we try to use some of the dam and produce the drainage features and bring out our flow directions. From flow directions, we look at our flow accumulations. You can see we have a very, very interesting drainage system in the entire area, which is actually controlled structurally. If you look at this place, this actually, we try to merge this also with our structures. If you look at this, you can see a very clear deviation from here, and you can see it continue here and here. And if you look at this place, this tells you so much. This unique feature here, this is not just coincidence. Something is happening here, and something actually happened here that deviated this water. So that will tell you the structures here aligning with this water might give you a kind of confidence level to build more structures around that particular area, because water drainage is one of the easiest way to recognize structures if you can actually place them very, very well. Then this also, we're building a stream order within that particular location to see our orders. You can see the first orders in different colors, blue. We have the second order, the first order here, the second order, and the third order in the green. So we have first, second, and third order kind of stream in this particular location built in our GIS environment. Also, going all along, we can, now let's look at some of the results we are trying to bring out here. At the end of the day, we're able to bring out the stream in this order in the entire regions. And we'll look at our, okay, this is the forest reserve. Now let's look at what we're able to bring out here at the end of the day that actually helped us so much in the field. Let's look at this. Okay. This is our thorium structures, the structures that we got from thorium here. This is our uranium structures. These are uranium structures, you know. This is our potassium structures. Then we'll look at these prospect zones. How do we mark these prospect zones? See the possible alteration zones. We're able to, you know, we delineate. Let's look at the structures. We brought out these radiometric structures fall within these particular alteration layers. And these are some of our geologic structures. We were able to bring out all these as our map. You know, we started looking at it and said, okay, which area are we concentrating? We looked at this area. You know, this is area we said we want to look at, and we move to the field to sample. You know, this is all the sample points based on samples. We are actually trying to ground truths, what we've actually done on the system. And we're able to come up with some interesting features. At the end of the day, we're able to mark some specific point. You can see where we got some interesting number. We are not able to assess this location as of the time this was actually carried out because it's highly, you know, a lot of valleys and vegetations cover within this zone. So this is a summary of the entire layering we're actually doing. There is another section of it that actually not be represented here just because of the sensitivity of the information we're actually trying to, but we're trying to see, we're not trying to do things that are theoretical or something we'll copy and paste. We're trying to show live things that are actually on the ground and what is happening within this particular region based on a project, you know. So with this, we can see how we can use GIS to work in our specific project of mineral exploration. The essence of it, what I would say is this: whatever mineral one is actually looking for, will tell you the kind of layer we are going to be sourcing for. Now, if you are dealing with, let's use the common minerals we are actually used to, which is gold, or every mineral, we know that there's no mineral that can actually occur without void, that will occur without void or openings, fractures, and some, you know, openings in the egg. So what are we trying to look at the first step? The first step, most of time, is we are trying to define structures. Where are the structures we are looking at? Apart from the regional structures trending, what are the auxiliary structures of the subsidiary structures we're actually looking at? You know, having brought out this on a regional scale, now we try to look at, okay, on a very local scale, can we find these structures? Maybe using some kind of ground magnetic surveys and all that. If the structures is very important there, we'll look at, okay, if you look at all the discovery of gold, what has actually played an important role? There are two things I've seen that play so much role in terms of gold. There's a paper I read trying to combine all the explorations that have actually been done on gold all over the world. the number one that actually giving so much rise to discovery of gold has been the structurals, coming to using geochemistry, combining these two. Most of the gold definitions using geophysics has been an indirect kind of rule, maybe to trap your structures before you now go using your geochemistry and all that. So in mineral exploration, you must find the layers that is very most important pertaining to actually what you are looking for. For example, if I'm looking for coal, if I want coal, I want to delineate coal washout, or I want to delineate some areas where the coal must actually be found on a local basis. After I must have done my regional analysis, on a local basis, the most important information and layer that I'll be using is the topographical layers that I'll be working on. I'll be much interested in how accurate is my topographic layer. You know, if my topographic layers are not very much accurate, I might miss out, because code actually controlled by topography, and a lot of weathering processes actually happens, and some places can be washed out. So that is just it. So we need to understand what we are looking for, and the most important layer we need to bring in into GIS environment in order to track out our minerals. Thank you. I think I will need to stop here. If time permits, I might show us some other kind of project and how we go about it in mineral exploration using GIS. Thank you.